So now let's start from first factor, that is temperature. Okay, so what is temperature? All of you know. And what effect does it have on evaporation? Is that rate of temperature is directly proportional to the rate of evaporation. It means that when you are increasing the temperature, the rate of evaporation will also increase, and if you are decreasing the temperature, the rate of evaporation will also decrease. So see, what is happening here is that when you are having some liquid and when you are increasing the temperature of this liquid, means you are giving more heat energy to this liquid. So the particles which a liquid is having, the particles which are present there, they will get more kinetic energy on heating. They will move at a faster rate. So means they are having more kinetic energy to go up, and when they will go up, because of this heat, this liquid will turn into vapor form or in gaseous form. Okay, so this is increasing the rate of evaporation. Wait, one more time, I'm going to explain you what is happening. If you are having a liquid and you are heating it, what is happening? On supplying heat energy, the particles which are there, they will try to move far apart. So in doing this, the kinetic energy of the particles will get increased, so they will go into the atmosphere with a higher rate, and when they are going into the atmosphere, because of this heat supplied, so liquid is changing into gaseous form or in vapor state. So it means what? On increasing the temperature, when the liquid is going up in the atmosphere, the evaporation is also increasing, and on decreasing the temperature, the when you will decrease, when you will remove heat, the kinetic energy will slow down, so less water will go into the atmosphere. Hence what will happen? The evaporation will also decrease. So we can conclude from here is that temperature is directly proportional to evaporation. Now let's move on to the second factor which is affecting evaporation, that is surface area of the liquid, which is also directly proportional to evaporation. The rate of evaporation increases on increasing the surface area of the liquid. See how this is happening. Means if you are having a liquid in a large container which is having more area, and if you are having a liquid in a thin, say for example test tube, and you are giving heat here also and you are giving heat here also, so the liquid will evaporate more quickly from here, because the liquid is exposed to atmosphere is here more in this case. So more liquid will evaporate from here. Hence what we can conclude is that surface area is directly proportional to evaporation. From here the surface area which is exposed to atmosphere is very less, so the number of particles which will evaporate from here will also be very less as compared to this one. So what can we conclude from here is that the rate of evaporation of the liquid can be increased by increasing the surface area of the liquid as in this case, and it can be decreased on decreasing the surface area of the liquid as in this case. Now moving on to the third factor, that is humidity which is present in the air. See, what is humidity? First, understanding the term humidity is very important to us. It is the amount of vapor present, or we can say amount of water vapor which is present in air is called humidity. In the atmosphere which is surrounding us, there are tiny drops of water in the form of water vapor which is surrounding the atmosphere, and these water vapor in the atmosphere is known as humidity, and we are not able to see this water vapor. So when the amount of water vapors present in the air is small, means when little water is present around us, we say when we have less water around us, we say that the air is less humid or air is dry, and when this it is dry, and when the amount of water vapor present in the air is large, we say that the weather is very humid or it is very humidity. So when the humidity of air is low, means water vapor which are present in the atmosphere, they are very less. So what will happen? This is our container and the surrounding, the water vapor is very less. So what will happen? They will go easily, the water will evaporate easily. So means if the temperature is less humid, more water will evaporate, then we can say more evaporation, because the surrounding air is dry, so more water will try to evaporate. And if there are so many water droplets in the surrounding, and we also have water in the container also, so less water will try to evaporate in the atmosphere. Why? Because already water is present in the atmosphere. So if the temperature is humid, so evaporation will be less. Okay, so what can we conclude from here is that when the humidity of the air is high, it means the conclusions which can be drawn from here is that when the humidity, wait, let me write it more clear. If humidity is high, then what will happen? Evaporation is low, and if humidity is less, so evaporation is more. The water evaporates more quickly in this case. And in the rainy season, because rain is falling down from the sky to the ground, what is happening? More water vapor is present in the atmosphere around the container or something, anything else. So that is why less water is evaporating in the rainy season, and that condition becomes very uncomfortable and sticky condition. Okay, now moving on to the fourth factor, that is wind speed or the speed of wind. All of you know what is wind? Moving air is called wind. Okay, so when the air is moving gently, moving air, that is known as wind. Now what is happening? The rate of evaporation increases with the increasing wind speed, so it is also directly proportional. See, suppose you have water in a container and the air is blowing from here to here, or we can say that the wind is blowing from here around the container. So what will happen? This air will try to take away the particles of water along itself. So means what? The evaporation will take place. Hence what will happen? Water will evaporate. So if the speed of wind is high, the evaporation will also be high, and if the speed of wind is less, the evaporation will also be less. So we can conclude from here is that the speed of wind is directly proportional to evaporation. I hope this is clear to you all. It's just a simple topic. Now moving further, we will look at some examples where evaporation brings cooling to us caused by evaporation. Now here we will be looking at some examples where because of evaporation cooling can be done or we feel cool and comfortable. Okay, first example, see what is putting alcohol on hand. What happens is, when you put alcohol or some ether or spirit sort of thing on the back side of your hand, what you feel very cool and comfortable for a small or short amount of time. Why this happens is that the alcohol which you have poured on your hand is in liquid form. Now when it will evaporate, so for a liquid, when it will evaporate, it will change into gas. For a liquid to change into gas, what is required? Heat is required. So this heat will be taken from your body, and when heat is given out, that is why you feel cool and comfortable. Okay, see what happens is that when you put some alcohol on your hand, so alcohol is liquid and it has to evaporate, which is in gaseous form. So when liquid has to be changed into gas, what is required? Heat is required, and this heat is taken out from your body or from your hand. So when heat is given out, so that is the reason you feel cold, and this cooling is by the process of evaporation. Okay, now moving on to the second example. Most of you might have gone to villages where water is kept in a pot. Okay, wait, let me write it clearly. Water kept in a pot. So in summers in villages, what happens when they don't have refrigerator, they keep some water in a pot, and this pot has tiny pores on its surface. So from these pores, what happens is water comes out from these pores, or water seeps out. Very less water comes out from the surface. Now when the wind is blowing, what happens is this water evaporates from its surface into the atmosphere, and on evaporating, again liquid is turning into gas. So what is required? Heat is required. Now this heat is taken from this water, and when heat is given out from this water, so what happens is, as a result, water cools down in a pot. Okay, in villages, what we have a earthen pot, and it has small amount of pores on this. From these pores, water seeps out, a small amount of water comes out, and when the wind blows, this water is converted into vapor form, which means liquid is turning into gas, and again this requires some energy or heat. This heat is taken from the water kept in this pot. Hence what happens is, when the heat is given out, water cools down in the pot. So this was a second example. Okay, one more example we have is of sweating, or we can say perspiration. In summers, what happens when we do a lot of exercise or physical work, so we sweat a lot. Now when we are sweating, water type of thing comes on our body, comes out on our skin. Now when wind is blowing, so again this water will evaporate into the atmosphere. In which form? It will in the vapor form or in the gaseous form. Now again what is happening? Liquid is turning into vapor or into gas. This process again requires heat. Now from where the heat is given? This heat comes from the body of the human body. Hence what happens? When the heat is given out, we feel cool. So sweating is one such phenomena in which a person the temperature of a person decreases down and we feel cool and comfortable. And this is the reason why we wear cotton clothes in summer, because the cotton clothes which are there, they absorb sweat, and when they are absorbing sweat, the water is coming on the clothes. So when the wind is blowing, it is taking this water from the clothes into the vapor form or in the gaseous form, taking away the heat from the body. And this, so what happens is that we feel cool and comfortable. So we feel cool and comfortable. So these are some of the examples which we see in our daily lives related to evaporation. Now we have another experiment to show the presence of water vapor in air. I have already told you that water is present in the form of water vapor in air around us, but we are not able to see it. So that is why there are some experiments which will let you know that this water vapor is present in the air. Since we cannot see it, so we can see it with the help of some experiments. What is the experiment is that? It is very simple. All of you must have seen this phenomena, and you can perform it at your home also. You take a glass, sorry, the glass is little bit small. You take a normal glass and you take some ice and you crushed it and you keep it in the glass. Now you leave it some say for example 5 minutes. After leaving it, what you will see that there are tiny drops of water droplets which has appeared on the outer side of the glass. This is the outer side and water droplets will appear here. So this phenomena shows that water vapor is present in the air. How these droplets have come? See, we have water vapor in the air, and when this air will strike the glass, so it will cool down, the water vapor will cool down and it will get condensed into liquid, or we can say water. So these are the water droplets which have been formed due to the condensation of the vapor which was present in the air. So this experiment clearly demonstrates that water vapor is present in the air. So formation of drops of water, wait, let me write it again. So formation of drops of water on the outer surface or on the outside of tumbler containing which is crushed ice, or you can simply write ice. It shows what? It shows the presence of water vapor which was present in the air. This is happening because the water vapor which was present in the air in the vapor form, when it is striking the glass, because the glass is cool because of the presence of ice in that, so what will happen is that this air will condense and it will condense to form water droplets. So this was the last experiment of this chapter. Now with this our chapter is over. I hope you all must have understood it well. So if you have understood it well, then please do hit like button, share it among your friends so that they can also learn it in a simple manner, and please subscribe to my channel. Thank you.